I rather like the constructions for today. So you'll need to have your compass handy. The first one is going to be you know what? Okay, yeah. We're going to construct an equilateral triangle. What does it mean to be equilateral? Equal on all sides, right. Yeah, all sides and all angles are equal. And what's the word that we used in geometry for equal? Congruent. Good. Yeah, they're congruent. It means they match. They're the same. They match. Okay? So what we want to do is we want to start, make sure you leave yourself a little bit of room. We just want to start with the side of the triangle. Make a line of some length. Not too long, not too short. If it's too short, it makes it tricky to do. Okay. So just make a line. I'm going to sort of put points on the end of the line, on my line, just to make it sort of a little easier to kind of see inside our little target deals. And now I want to measure it, but I don't measure it in inches or centimeters. I measure it with the tool, right? So I get my pencil hole lined up and my bullseye lined up. So this measures the length of the side, and all we have to do now is I'm going to strike an arc out here in space above my line. Now, just like the spokes on a wheel, the distance from this arc to this point, which was the center of the arc, or center of the wheel, any point on here is an equal distance to this as these 2 points are to each other. Now what I want to do is, without changing my measurement, I'm going to go to the other point and I'm going to strike an arc across that first arc. Now I have the third point of my equilateral triangle. And using radii of circles, radiuses, it's kind of like rhinoceros. Is it rhinoceri or rhinoceroses? It's neither?
I don't know.
I don't know either.
Neither of those sound right.
I think my life, I can get by on my life, and people will know what I'm talking about if I'm saying rhinoceroses, right? Or rhinoceri, right? Something like that. What's that? Rhinos?
Yeah.
Isn't that a drink or something like that? Okay. So check now, measure. See if you aren't pretty close to having 3 equal sides. I'm going to do it in centimeters. Mine looks like my first line was about 5.5 centimeters, about. And I'm pretty close to 5.5 centimeters there, and I should be pretty close to 5.5 centimeters there. Maybe a little less on that one, but close. Again, you're not going to make an absolutely perfect thing with these tools. They're good tools, but they're not. There's a little bit of imperfection there. So equilateral triangle, could you do another one? Okay. Let's look at a parallelogram. Construct a parallelogram. So to do a parallelogram, what we need to do is we need to start with an angle. But the sides of the angle have to be different lengths. So I'm just going to make an acute angle here. One side will be kind of long and the other side will be kind of short, a little shorter. Okay. Now, what's important about a parallelogram in terms of the sides? They're parallel, right? That sort of is in the word, right? So if I kind of sketched a little parallelogram over here, what could you tell me that's supposed to be true about this side and this side? They're parallel and they're equal, right? So this is equal to this. What can you tell me about these two? They're parallel and equal. That's a property of a parallelogram that you need for the construction. You have to understand that that is true. So here's what I'm going to do. I'm going to start by measuring my short side. I'm going to go ahead and put my points in a little darker here. I think that's helpful. I'll put a point out here. So I'll make that two sides of my parallelogram. And I'm going to measure this length here. Now, where does that need to translate to? It needs to translate over here, right? So I'm simply going to move this over to the other point, and I'm going to strike an arc. It doesn't have to be super long, but it has to be long enough that I think that parallel line is going to go to that somewhere. Now, human eyes are pretty good. We could probably do something like this. If I slide this over just so, I think that point's right about there. But we don't need to rely on that. We want to rely on the tool itself. So the next thing I'm going to do is I'm going to measure the length of this line. So I'm going to put my eyeball in that vertex there that we started with, and I'm going to get this point in there. Get that measured up. And then I just come up here and I translate that difference in an arc up here. Now, we should have a point where the two arcs cross. What do you think? Is that going to be your fourth point?
Yeah.
It should be. It should be. Ish, yeah. It's pretty close. I bet it's pretty close, given the limitations of our tools, but I think they're actually pretty good. What do you think? Does it look pretty parallelogram-ish? All right. So before we go on, what I'd like you to do is try, on your own, try to make another equilateral triangle and try to make another parallelogram. I'll kind of walk around a little bit and, make them a little different size. Maybe make the parallelograms bigger, smaller, whatever. Do the same with your equilateral triangle. And then we'll go on. We've got one more shape that we need to learn about that's actually pretty fun and cool. So as I was walking around, anybody else? Anybody else? Okay, you got it? All right, ready for the quiz?
Yep.
Good, all right, that's the right answer. Okay, let's learn to construct one more thing. We want to construct a hexagon. The hexagon's a really cool shape for construction. And math in general, there's some really cool properties about it. So the first thing I want you to do is, and leave yourself some room, okay, you'll need some room, is I want you to make a circle. Don't make it too small. I mean, if you're using up a piece of paper for this, that's okay. Make yourself a circle. And make sure, oops, you know what I should have done first? I screwed up. Put a point where the center of your circle is going to be first, because you need that center of the circle. So construct a hexagon. Start with the center of your circle. Bless you. Actually, come to think of it, maybe I didn't. Bless you. Maybe I didn't need the center, but I think it'll be helpful. So get a circle. Don't change your compass. Don't make any adjustments to it once you've made your circle. What do we call the distance from the center of the circle to anywhere on the outer edge? A radius, right. I think of it as a spoke, right? A spoke to a wheel, but it's a radius. And our tool should be adjusted for exactly that, a radius. Now, pick a spot on the circle, anywhere. Make a mark. Okay? Make a mark anywhere on the circle. It doesn't matter where. Now, that is going to be where you put your eyeball. Put your eyeball and then strike an arc across part of the circle, like this. So this distance is the same as this distance. Okay? Now, that's a new point. I'm going to put the eyeball on the new point, and I'm going to do that again. I'm going to strike an arc across the circle and create another point. And this distance should also be, from here to here, should be the same as the radius of the circle. And I'm going to keep doing that. And you may not end exactly, but you should come pretty close to ending on the point that you started on. Okay? Ideally, it would be exact, but not everything in our world is perfect. So we keep doing this. And when you get to the last one, go ahead and see how close you are. Yeah, I'm not as close as I'd hoped to be. I'm a little off. But pretty close, right? That's a limitation of the tool. If our tools were perfect, I would have marked off 6 spots and I would have hit right exactly on the spot that I started. Okay? So, now what I'm going to do is I'm going to ignore this little piece here. I just was curious to see how close I came. I'm going to ignore that little piece right there. Now I'm just going to connect the dots sequentially. Boom. 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 And a little bit shorter side there. Hexagon. Yes, sir.
How we can make shapes with no sides on there?
Um, um, want me to show you how to make a square? It becomes tough at that point because The thing that's special about a hexagon that makes it easy to construct is this. If I draw the diagonals, my diagonals should go through the center, but remember, my construction is a little less than perfect. It's close, but it's not exact. But the thing that's cool about a hexagon is if you draw the diagonals, you get something special, which is why this works. All of these pieces, you see all the triangles in there? It makes 6 equilateral triangles. And no other shape will do that. So constructing a hexagon is kind of a fun and easy construction. I think that's one that you need to know for the test. I'm pretty sure that that is one for the test. It's not a hard construction, you just have to remember how to do it, right? It's a bunch of radii. So would we say that this is an inscribed hexagon, or what's the X word? Exscribed? No, that's not really a word. Circumscribed, thank you. Would we say inscribed or circumscribed? Circum, you think? I'm thinking it's inscribed. It's inside the circle, right? Circumscribed would be, yeah, that the circle's actually on the inside. It would touch here and here and here and here and here. Yeah. So I'm going to suggest you try another hexagon. See if you can do that again. You don't have to do the diagonals. I just wanted to show you that it creates 6 equilateral triangles. Try another hexagon while I'm handing out the assignment.